Hello. A derivative function represents the equation of the slope over the tangent line anywhere on the graph of the function wherever the function is differentiable. When working with derivatives, there are multiple notations we can use. In this video, we will talk about 4 notations. The first one is the Lagrange's notation. Lagrange was an Italian mathematician and physicist. With this notation, given a function f of x, the derivative is f prime of x. So this notation uses the prime symbol and we read it f prime of x. If instead of f of x we have a function y, then the derivative is y prime. Now, as an example, let's say that f of x equals 4x squared. Then the derivative, according to the power rule, is 8x. And if y equals 4x squared, then y prime equals 8x. This notation is most commonly used in Calculus 1. For the second derivative, we write f double prime of x. For the third derivative, we write f triple prime of x. And for higher order derivatives, we write the numbers in parentheses to distinguish a derivative from an exponent. For example, for the fourth derivative, we write 4 in parentheses. The next notation is the Leibniz notation. Leibniz was a German philosopher and mathematician, and he was one of the creators of calculus. Given a function y, with this notation, we write that the derivative of y is dy dx. So we can read this as the derivative of y with respect to x, or just simply dy dx. If we have a function f of x, then the derivative is ddx of f of x. And again, if y is 4x squared, then dy dx is 8x. And if f of x is 4x squared, then ddx of 4x squared equals 8x. This symbol ddx is called a differentiation operator. The Leibniz notation is used in differential calculus and is very common in the integral calculus, differential equations, multivariable calculus, and physics. The second order derivative, we write it as d2y dx squared. The third order derivative is d3y dx cubed. The next notation is the Newton's notation. Newton is another inventor of calculus, and both Leibniz and Newton developed calculus independently at the same time. Newton's notation uses a dot over a function. Given a function f of x, the derivative is f dot of x. And for a function y, the derivative is y dot. So again, if f of x equals 4x squared, then f dot of x equals 8x. And if y equals 4x squared, then y dot equals 8x. The Newton's notation is mostly used in physics and mechanics to represent derivatives with respect to time. Now for the second derivative, we use 2 dots. For the third one, 3 dots. And for higher order derivatives, we write a number that represents the order over a dot. So if we need the fourth derivative, we write y with a dot, and over the dot we write 4. And now the last notation is the Euler's notation. Euler was a Swiss mathematician, and this notation uses the uppercase letter D to represent the differentiation operator. Although this notation was introduced by another French mathematician. So with this notation, given a function f of x, the derivative is d of f of x. We can also write this derivative as d sub x of f of x. So the subscript x tells us that this function is differentiated with respect to x. So if the function is 4x squared, then d of 4x squared equals 8x. This notation is useful when studying differential equations and differential algebra. For the second derivative, we write d squared of f of x. For the third derivative, d cubed of f of x. And for the fourth derivative, d to the fourth power of f of x. So now we have the main four derivative notations. Thank you for watching.